Welcome to our review on making crude oil useful. First thing we need to understand then is a little bit about crude oil. So crude oil is a fossil fuel, and it was actually formed from the remains of living things that were living in our seas millions of years ago. As they died, they then sank down to the bottom, and then all of the little bits of sediment built up on top of them over the years, and they became buried deep underground. Now, over many millions of years, that's turned into crude oil. Now, crude oil is a non-renewable resource, and what that means is that it was made a long time ago and we're using it up at a faster rate than it can be made. So what we find is that whenever we're asked about what non-renewable means, we need to say that it's being used up faster than it's being made now, or it's a resource that is going to run out. Now, we've got two other fossil fuels as well, which are coal and natural gas. And all of these fossil fuels are described as finite resources. So this just tells us that there's a limited amount of them available. So if we continue to use them, then they will run out. When we think about crude oil, what we're actually talking about is a mixture of many different hydrocarbons. And a hydrocarbon is a substance made of hydrogen and carbon only. Now that is one of the exam board's favourite questions to ask you. For 2 marks, you get 1 mark if you say that the hydrocarbon is made of hydrogen and carbon, and the second mark, as ridiculous as this sounds, is for the word only. So 2 marks, hydrogen and carbon for the first, the word only is our second. Now what we need to do is, we don't want to try and use crude oil as that whole mixture of hydrocarbons because it wouldn't work. So we need to separate them somehow, and the way we do that is through this process called fractional distillation. What we can see in the picture on the right hand side there then is the fractionating column. So this is the actual bit of machinery that we use to separate out all of those different hydrocarbons that we find in crude oil into the individual fractions. So what we can actually see at the bottom left there, what we're going to do is we're going to have our crude oil. Now we're going to heat it up first of all, and then pipe those vapours into the fractionating column. And the fractionating column has what's called a temperature gradient, and all that means is it's hotter at the bottom and cooler at the top. Now because we've got this mixture of hydrocarbons, then they all have different boiling points. So what we actually find is that the hydrocarbons with the lowest boiling point are going to be able to travel further up the column, because remember, it gets cooler the higher up we go, so that what we're going to find is the one with the lowest boiling point gets to the highest point, and that's going to leave the column at the very top as a gas, and that fraction is LPG. If we come all the way down to the very bottom, we can see we've got this fraction called bitumen, and that one has the highest boiling point. It's the longest of all our hydrocarbon chains, and it's got the highest boiling point there. So what we're going to find is that one is going to stay at the very bottom because it's got the highest boiling point, and it's going to stay where the column is the hottest. We will find the other ones, as you can see throughout the different side there. So we've got petrol, paraffin, diesel, heating oil and fuel oil. They've all got their own boiling points, and therefore they're going to get to different heights in the column. And it's all down to the fact that the different boiling points are going to condense into a liquid at different temperatures as you go up that column.